Hi, this is the Temder podcast, Innovation at the Edge with Open Source. Today, we got a visit from two of authors who have written a book about embedded Linux, Chris Simmonds and Frank Vasquez. So, welcome, guys. How are you doing today?
Yeah, doing great. Good to be here. Thanks for inviting us on.
Thank you. And as usual, our co-host, Cliff Brake. How are you doing, Cliff?
Yeah. Looking forward to the visit here.
So Chris is a well-known presenter, trainer, and subject of embedded Linux. Frank has shipped a number of products, using embedded Linux, and he also leverages his experience to help other teams. So we'll basically learn about their book writing experience, along with also they are super embedded Linux engineers. So we'll have a lot to cover today. So Chris, what was your career like so far? What do you do today, and what's brief overview of what you have done throughout?
Yeah, so I started doing stuff with open source back in about 2000, 2001. Before that, I did a whole bunch of stuff, but it's not interesting in this context, I don't think. But 2000, well, a little bit before that, I set up my own company and started doing consulting. And then, I discovered this Linux stuff and it seemed quite interesting. So I sort of focused on Linux, and I was always interested in embedded systems. So embedded Linux became the kind of thing that I was doing. And that's all going fine. And then a chance meeting with a guy who was running a training company, a guy called Niall Cooling. He spotted I was doing this Linux stuff. Didn't seem particularly interested at the time, but then about a year later, so 2002, I guess we're up to now, he just called me up out of the blue and said, "Hey, Chris, that stuff with the penguin you were doing at that show a year ago, are you still doing it? Would you like to turn that into a training course for us?" And that was just so random. So I said, "Yeah, give it a go." So I started doing embedded Linux training with his company called Fibas here in the UK. And that's kind of how I got more deeply involved in this kind of whole education concept that I've been doing pretty much ever since. So that rolled along quite nicely for a while. It still rolls along. But then I got the idea of maybe writing a book sometime, and I kind of played around with a few ideas and didn't really go anywhere. But then again, another random call out of the blue. So my life has been controlled or determined by random calls out of the blue, I think. I got a call from a publisher called Pact, literally completely unexpected. And they said, "Hey, we've got a title for a book called Mastering Embedded Linux Programming. We just need somebody to write it for us. We've heard you do embedded Linux. Would you like to do that?" And I said, "Yeah, as it happens, I would." And so I started writing the book. That was in 2014. They contacted me. The book was published December 2015, so a little over a year later. And that's how I got involved in the publishing world as well. So that's Let's leave it at that point, and we'll come back to some of these things as we go on. But that's kind of how I got to be doing what I am doing now.
Awesome. Yeah. So Frank, what has been your career like so far?
Well, I'll start at 2009 because that's when I got involved with embedded Linux. Before I've always been a software engineer since I started my career 20 years ago. So I'll be doing software professionally 20 years this coming January. So I'm surprised I lasted that long, to be honest. I did not expect to be working as an engineer that long. I would say that I am so some people call themselves serial entrepreneurs. Like I'm I'm a serial founding engineer, so I tend to get involved with early stage startups that are very small, and it's always in the hardware space. So I'm, because it takes a certain type of person to be able to talk to an EE and explain why the software isn't working, and I enjoy that. Like I that close collaboration with EE. So I'm always looking for like hardware startups to attach myself to, kind of like a parasite.
Awesome.
But now I'm actually looking to pivot away from that and get into training, just like Chris did. So.
Yeah, I think that's definitely an area we'll I've some interesting thoughts and questions about, and maybe go from your book writing and then towards that. So Chris, you said earlier, 2014.
Yeah.
What prompted you or inspired you to write an embedded Linux development book, and what was the state of art around you when you started?
Yeah, well, good points. So I had, I put together these training courses on embedded Linux, and that was 2002 onwards. So I was kind of fairly early on in the embedded Linux story. And in around about that time, 2000, 2005, there were a bunch of really good books on embedded Linux. Karim Yagmor had one, Chris Hallinan had one, and a whole bunch of others. And they sat on my bookshelf, and they kind of informed the stuff that I was teaching. But then, maybe a little bit like me, they each kind of dropped by the wayside a little bit because they were doing other things. And so by 2014, there wasn't, in my opinion, an up-to-date embedded Linux book. So I kind of identified this, and I was kind of, thinking of, I've got all this material, I do all this lecturing, I go, from zero to kind of guru in a 5-day training class. Well, okay, not quite, but nearly. So I thought, yeah, that should be easy to turn that into a book. But the problem is that getting into that is quite tricky. So then, as I said, somewhat out of the blue, Pact called me up and say, "Hey, we've got a title. We would like you to write it for us." And I thought, well, okay, this is pretty much handed to me on a plate. Let's just do it. So the original idea that I had was I'd literally take my lecture notes and just turn them into a book. I thought, how can that be? I do this, almost every week. But then when you start writing stuff down, you realize that it's not just a lecture. You've got to do a lot more due diligence. You've got to test everything out. Part of the idea was always that there would be some hands-on sessions. So it turns out that when you're learning something, if you simply read about it, the information retention is actually quite low. But if you actually do the exercises, which hopefully people do the exercises, if you actually do the hands-on stuff, then the information retention goes up enormously. So it was always my idea that everything described in the book would be backed up with practical exercises, so people could get out, in those days, a BeagleBone Black, and they could write their first program, and they could do some real-time programming and all the other stuff.
Mm-hmm.
Anyhow, having to go through and validate all those labs and checking everything worked was a lot more effort. And then also you need to go into a lot more detail. You need a lot of words to fill a book, to put it simply. So it actually was a lot harder than I thought it was going to be. Mm. So hence it took me, basically a year to write the whole damn thing. And I also discovered that, at least for me, it didn't really work just doing it kind of evenings or weekends. Apart from anything else, I had a young family to take care of at the time. So eventually, for the last 6 months, I worked on it pretty much full time. And then eventually I got the whole thing finished just before Christmas 2015. And then finally, I sent the final draft off. I was just looking through the email correspondence between me and the editors at Pact. And I can almost see in my tone in the emails a sort of sense of relief when I say, I've got it to you. Yeah, here's the final thing. And I think my final message in that tray was, we're good to go. Publish it. And they came back and said, okay, it'll be published in 3 days' time. And it was. So that was my journey, and that was the kind of rationale. Well, I suppose also the rationale was that I wanted people to know about embedded, which is the most fantastic thing you can do with a computer is use it to turn lights on and off and control motors and all that kind of stuff. All this stuff people do with AI and kind of web apps and such like, it's completely irrelevant and pointless, in my opinion. If it doesn't turn an LED on and off, it's not worth doing. So that has been my philosophy right from the start. And yeah, it turned out that has been fairly successful. I'm very, very pleased about that.
Yeah. And Frank, when did you get involved in the project?
It was, I believe it was 2020 when Pact reached out to me, and I did not know Chris. I wasn't really known in the industry. I think literally they were just like, just taking swings at anybody who with some experience who was open to the idea.
Well, I'm glad they found you.
Yeah.
Me too.
So we are into now 4th edition, if I'm right. So it's pretty sure that it's been revised a few times. So what changed in the world of embedded Linux that forced you to do 4th editions instead of just like an errata of a PDF or something like that?
Well, if I just jump in for a moment, I mean, everything's changed. If you look at the format of the 1st edition, it's pretty much do it yourself. I mean, when I first started doing embedded Linux back in 2000, roughly speaking, there was very little tooling available. So Yocto didn't exist, Open Embedded didn't exist, Buildroot didn't exist. So you had to do everything from scratch. And that was a lot of fun the first time you do it. Making your own cross-compiler is quite a challenge, and you feel quite good when you finally get it to cross-compile. And building your own root file system and getting BusyBox installed and whatever, it's all good fun. But that kind of pales a little bit. So then we started using Buildroot and Open Embedded, and that kind of got into it. So so the state of embedded Linux when I wrote the book, 2014, we'd advanced a little bit. So Yocto did exist by that point, and Buildroot did exist. So that's what the book is based on. But the way that embedded systems were used in those days was still fairly basic. We weren't too much worried about security because, hey, there were hackers around, but they were mostly good hackers. We didn't worry too much about the bad guys then. And also the things didn't do that much. They didn't really expose that much. So going from that point, and Frank may disagree with me slightly here maybe, but this is my perspective. Going from that point to where we are today, embedded has just become so much more functional. The chips are incredibly more powerful than the ones we were using way back. But also in the environment, everything is connected, whereas way back we didn't always, things were generally not connected to a public network, so security wasn't such a big issue. Whereas now everything is linked to a public network. And so you have all the issues that we have. So it has changed tremendously.
Yeah.
And I'll hand over to Frank to bring you up to date with the things that he's been doing in the 3rd and 4th editions.
Yeah, so the biggest change was I brought in the Raspberry Pi 4 in the third edition. And, as we all know, that supports Bluetooth and Wi-Fi, which are very complicated to get working on most dev boards. But with the Pi, it just works out of the box. And yeah, so I'm actually one of those insane people who use Raspberry Pis inside of commercial products. The thing you're never supposed to do. I've done it, and um, so yeah, I figured I learned a lot doing that. I did it using Buildroot, and so I tried to share a lot of what I learned in the third edition of the book.
Yeah, and the fourth edition, you also cover more machines, right? And 64-bit.
Yeah, so the fourth edition, I swapped out the BeagleBone Black, which was the only dev board in the first two editions. I swapped that out with the Beagle Play, which is 64-bit ARM. So the fourth edition says goodbye to 32-bit ARM completely.
Well, that's awesome. I think you describe the book as learning path as well as references. So as authors and trainers, how have your teaching style evolved between these editions? So, in other words, have you included, your learnings from writing the book into how you teach and vice versa?
So from my point of view, yes, for sure. I mean, you never stop learning. So every time step back a little bit. One of the interesting things is, as a teacher, you actually learn from your students. They think they're learning from you, but in reality, you're learning from them. And so every time you run a training class, you get a whole new bunch of perspectives. New things have happened because people have gone and misinterpreted perhaps your instructions and done some really, really interesting things. And you think, oh, I never realized you could do that. So you're constantly, it's a constant kind of feedback. So you keep on learning stuff, and then you build that into the training lecture notes, and you also build it into the next edition of the book. And then as you're researching the book, like I say, you can't just take the lecture notes and turn them into a book because there isn't the right level of detail. So as you're researching stuff, you learn new stuff again, and that gets reflected back into the lecture notes. And it's a very iterative process. And you just keep on building stuff up. And like I say, you just keep on learning stuff because there's always new stuff out there to learn. And it keeps you going. If you were doing the same thing over and over, it would be really boring. But turns out, as a teacher, no two classes are the same. They're always different. There's always new stuff happening. So yeah, the short version of that really is that everything keeps on evolving, and each informs the other. I hope my students feel the same.
Yeah, for me, the book got me. The book forced me to become a public speaker. So like I had to, start presenting at technical conferences to promote the book. And the first one I ever did was the Yocto Project Summit a few years back. And so I did like a lightning talk. It's the first time I've ever done anything in front of an audience like that. And it was all about runtime package management, which I know how you all feel about that. But I was like, and yeah, people seem to be really into it. I got a good response from that, and I started doing. Then I did like, the open source summit in Seattle after that, and then And then Chris got me to do FOSDEM when it was online
I
during
remember that.
the pandemic.
Yeah.
And so that was fun. And yeah, so I've just been speaking at conferences ever since. And now I'm starting to do workshops. So I just did a workshop at the RISC-V Summit. Well, I ran into you there, Kem. So yeah, so it's kind of gotten me in front of an audience, and now I'm starting to, what started out as like, presentations and just slideware are turning into workshops and hopefully, 4-day training courses.
Yeah,
Mhm.
yeah. So is there any like conference talks you gave, or any topics you covered there, that turned into a section or a chapter of your book, or,
No, but well, I can't speak for Chris, but like for me, the I do cover runtime package management in the book, so I added that. And using Yocto, and that turned into the lightning talk that I did at the Yocto project. So it's not like the stuff I do outside informs the book. It's the other way around. The book informs the stuff I do outside.
Yeah, I would echo that, in that a lot of the talks I've given over the years have really been kind of snippets from both from the book and from my kind of general training class. It makes sense to, so when you go to a tech conference like OSS or whatever, a lot of the talks are talking about the latest technology changes and the latest memory management techniques or whatever, which is great. We all need to know this stuff. But there's also another layer of people of talks that people really want, and that's some of the basics.
Yeah.
So I was never working on the very latest tech, because I was always teaching people how things work. So I see my role at most tech conferences, at least, to be kind of filling in some of the basic stuff. So we talk about, how does Yocto work? In fact, one of my not successful. One of the talks that quite often gets referenced is a talk I did a couple of years, about 3 years ago, which is just basically an intro to Yocto. And a lot of people reference that as being, hey, it's a great introduction to Yocto.
Right.
So it tends to be that way around. Like I said, I see myself as doing the basics rather than doing the snappy new stuff.
Yeah.
Although I do some snappy new stuff as well. Just want to put that out there. But my real function is kind of the basic layer of training. And then more recently, I've become a bit more interested in community and community aspects, and what it is that you need to make a good community out of open source in general.
Yeah. Yeah, we'll cover that. It's very interesting. So I think, you guys just didn't write the book, but, you also invited your readers into this community space and, and interacted with them in community. So probably that also shaped, the later editions of the book, or maybe your own thinking in some ways. But before that, you mentioned that embedded Linux landscape has changed quite a bit over time, and there has been custom systems, open embedded. Yocto came along, and then Buildroot, Android, which basically started getting into more than mobile space, and then some of the binary distributions, like Debian based embedded Linux systems were created, and and Frank just said he moved to a 64-bit reference for the newest edition of the book. So how has it changed over a period of time? And what do you think that, who would basically fit in the bill, or is it all of them, or is it one of them, or where do you see some gaps?
Do you want to take that, Frank?
Okay, I'll take it first, but you need to talk about it too, because like you're the Android guy.
Oh well, yeah. I'll yes. I really want to talk about that. It's true. Go on.
So yeah, it's changed tremendously, and then it also, like, relative to like how other things change, it's pretty slow, right? We're still in the Stone Ages compared to what what other people are doing in software. So it's like yeah. I mean, the tools have improved. I would say like Yocto has eclipsed Buildroot at this point. I don't think I don't even think Bootlin thinks like Buildroot is where it's at anymore.
Okay, I'll ask them next time I see them.
And so I like that battle to me is over. That Buildroot versus Yocto, like it's Yocto, like no question in my mind. I'm not saying that there isn't a place for Buildroot. I'm just saying, like, long term, if you need to scale, to hundreds of thousands of devices, you're not going to do it with Buildroot. And like meanwhile, the tooling in Yocto is just, we have CAS, we have this VS Code extension with all the bitbake syntax. That stuff helps a lot. And again, it's like the community. It's a thriving community. There are big companies invested in this. AWS, Garmin. It's ARM. You got Ross Burton, or contributing. I mean, you yourself, Kem. I mean, you're a monster. You look at all your contributions. So yeah, I mean, you could do a lot worse than betting on Yocto, but also it's a house of cards in a lot of ways. It's complicated. It's big. I mean, like, people. I know we're going to get into AI at some point, and LLMs and coding with LLMs, and so what do you have with Yocto? You have a huge monolith, right? It's impenetrable for most people. The LLMs just flail. You point it at a layer, and it doesn't know what to do. Its window of context isn't big enough to process the all of bitbake, and so that's a problem.
Yeah, 5,000 global variables. So it's.
So yeah, that's my stance on it. Like, it's obviously it's progressed compared to what it was. It's progressed so much, but I mean, we're still such a long way to go. And yeah, so like, the binary distros that you're talking about, that's attractive to a lot of people because that's what they understand.
Yeah,
it's like you bitbake. These words mean nothing to them. Debian, on the other hand, that's something they understand.
Yeah. So, Chris, what's your take on it?
Well, I don't see it as being any kind of battle here. I mean, Buildroot and Yocto, and also other solutions, they're all doing different things, and they all have their role. So there are places when Buildroot is the best thing to use. There are places when Yocto is the best thing to use. So my take is that Buildroot is easier to use. It's kind of menu driven mostly, and and the builds are much faster, so you can put together a prototype in like, I don't know, a couple of hours, maybe less than that if it's a well-known target. So Builder is really great for proof of concept, and it's great for products which have a fairly small bunch of people working on them, relatively small scale stuff. So that's my take on that.
Mm-hmm.
The problem with Buildroot is it doesn't really scale that well. So if you have 20 or 30 people working on a team, they're going to keep tripping over themselves with Buildroot, because Buildroot, for example, doesn't have the concept of layers, and it's not so modular, and it doesn't have BB appends, so you can't modify a recipe so easily, and so on. So it doesn't really scale that well to teams of, I don't know, 6 or 8 or 10 or whatever the number might be, in which case you come in with Yocto. And also Yocto is much better supported, so most of the SoC vendors and most of the board vendors do have layers, BSP layers for the various things. They are quite often terrible, by the way, but that's a different story. But there is something there. So I would say Yocto must be the go-to if you're building a moderately complicated product and in large volume and with a largish team. But then the other stuff, we talk about Debian and similar things. So sure, Debian makes a lot of sense if you're doing something, if you want a binary distro, so you don't want to mess around with compiling stuff. And if you're doing something relatively straightforward, so it tends to get built into, I don't know, routers and that kind of stuff. The big problem with binary distros, however, is what's known as the golden master approach. So if you naively take your Raspberry Pi, for example, and you take Raspberry, which is basically Debian, and you say, well, I'm going to build this into my I don't know, webcam, which I'm going to sell. And so you muck around with it, and you add a few packages, and you delete a few things, and you tweak a few configuration files here and there. And you end up with what's called a golden master. In other words, you have a configuration which works on your machine. And you're not exactly sure what you changed to get to the state that it's currently in, but you daren't change anything else in case you break anything. So you end up with this kind of fragile thing called the golden master, and then you just replicate that.
Yeah.
Fine, but then it's a nightmare to maintain, and quite often you end up with products that are basically stuck on a particular version of Debian with a bunch of weird changes to it. So don't do it that way is essentially what I'm trying to say. There are ways of doing Debian properly, doing embedded Debian properly, and there are build tools. Essentially, you can build Debian the same, or in a similar way to the way you build Yocto, but build it from binaries instead of source code, which is fine because those packages are maintained upstream for you. That's nice. But you do need to do it in a sensible way. You can't just hack around and create a golden master. So, yeah, the message there is whatever you do, if you're going to use Debian, do it properly and don't just create a golden master.
Yeah, you definitely want to know how you did it. That's important. So
it's got to be reproducible. You need to be able to start from a blank sheet and have scripts, have algorithms that will algorithmically recreate that thing from scratch, from upstream packages or whatever. If you can't do that, you don't have a product.
Yeah. I think for products, the repeatability is very, very important. Like at any point of time, you should be able to repeat the process. And if that doesn't happen, then it'll come after you at some point of time. So
absolutely, and that's why Yocto and to a lesser extent Buildroot are complicated, because they can build it from scratch. Yeah. You can blow everything away as long as you have the recipes and the layers. You can build the whole thing from scratch, and the build should be binary identical to the one that you had previously. And that binary reproducibility is very important.
Right. Yeah, I think there is a lot of work, at least in Yocto, that has gone into the reproducible builds and
Yeah.
immutability and that sort of like inherent features that take a long time. If you look at even today, there are certain packages in meta open embedded which are not reproducible because you need to fix them and you need to first find what the problem is, and they're hard problems at times. So, but
Yeah.
I think you're right that those are
But
like really important.
People may say, why is it that the first thing you do with Yocto is build a cross compiler? Why can't we just use an off the shelf cross compiler?
Right.
And the answer is, if you don't build a cross compiler from source code, you don't know exactly how that compiler is configured. You can't go back if you need to and find out exactly how that compiler works. And if there's a bug that turns up, you're going to need to do that kind of stuff.
Yeah.
So that's why Yocto starts by building its own cross compiler and its own hermetically sealed environment.
Right.
It takes a long time. It takes a lot of CPU cycles, but it's fundamental to the way that Yocto works.
Mm-hmm.
And Buildroot as well. Buildroot also does the same thing. I just said that as well. But if you contrast that, if I may just segue into this, if you contrast that with Android, so I do a lot of Android stuff as well with AOSP, the Android open source project.
Mm-hmm.
So in some ways, AOSP is similar to Yocto and Buildroot in that it's a build system. You have something which looks like recipes. They're called blueprints. And you have a build tool called Soong, which actually builds the whole thing. So, there are a lot of similarities.
Mm.
And you set up your blueprints, and it's going to build whatever Android image you want, and you type M, which is the invokes the build from scratch, and away it goes.
Mm-hmm.
But it doesn't, for example, do things like create a cross compiler. It uses a binary toolchain, and tracking down exactly what that toolchain is kind of tricky because it's not directly upstream. It's based on Clang and whatever, but essentially what the Google engineers have done is they've taken Clang and they've hacked it around a little bit, and then that's what they ship as the binaries. And if you want to reproduce that and see exactly what they've done, it's not entirely obvious, and it takes quite a lot of effort to work out how the Android Clang differs from the regular upstream Clang, and all these kind of things. So, hey Google, you could do better. You could do it the way that Yocto does it. Just saying, in case somebody from Google's listening.
Yeah, certainly. I think there's everything. All of this have reasons, and you can have accelerations in there, like Yocto has shared state, which can help you to speed up some of those additional computation that you need. But I agree that I think you need basically a lot of this is there for a reason that's beneficial.
Yeah. And Android doesn't even have the shared state cache or anything similar to it. It's crazy.
Yeah. All right. So I think you mentioned about communities, so you probably interacted with different communities out there in open source, Yocto, Buildroot, AOSP. So what's the importance of community to you?
For me, the community really is everything. Because in some people's mind, probably the majority of people's minds, open source just means free software. So, it's open source. That means I can download the software. Great. But really, that's not what open source is about. Open source is about sharing the load, sharing the knowledge, and being able to, on the one hand, share the code, but also to share the knowledge of how to use that code and also how to improve that code. So you get the feedback and you get a virtuous cycle whereby the more people use the software, the better it gets. So that is what community does for you. And if you look at Yocto is a good example of that. Yocto, as I think you may have said, is quite a small group of people working on it directly. I don't have any numbers in my head, but it's not thousands. It's more like hundreds of people who regularly contribute to Yocto. It's probably down in the dozens, maybe. I don't know. Ken, you might have a better number in your head than I do.
Yeah, I think you're about there.
So it's not a huge community, but it's close knit, and also anybody can join in. You have the Yocto mail lists, and if you have a problem, people can post a question on there, and generally those questions get answered pretty quickly. So it's also a kind of self-support thing. So that's, in my opinion, Yocto is a very good example of a functioning community where everybody does the best that is needed to make the whole thing work. But I mentioned Android. I should maybe expand on that a little bit. I've been doing stuff with Android ever since the source code was made available back in 2009, I guess it must have been. But I always looked at Android as being basically just embedded Linux, which is what it is. So I looked at the way it's built, and I looked at the way the code works and whatever. I thought, well, yeah, it's just another embedded Linux. So I and many other people set out building Android into embedded devices of all kinds. So test and measurement equipment, oscilloscopes, medical equipment, navigation equipment. You would be surprised the kind of things that run Android. Mm-hmm. But the thing that I keep on coming across is that there isn't a community based around Android, or at least not around the AOSP part of Android. There's plenty of community around apps. I'm not interested in apps. But if you look at the operating system, there's nothing. Google themselves are not interested in community. They don't really, at least the Android developer group aren't really interested in their stuff. So that's a big pity, and maybe we'll talk about this later on, but I've put some effort into trying to create a community and to create a place where people working on AOSP lists can come together and share stuff.
Mm-hmm. Yeah, I think the AOSPDAVs.org is what you have started. So would you like to talk a little bit about that and what you intend to do there and where it is?
Yeah, sure. So this keys in a little bit to something which I think Frank wants to talk about, which is the Linux Plumbers conference. So the AOSP devs started out at Linux Plumbers last year in Vienna. Mm-hmm. And so Plumbers it's an interesting conference in that it's more of a collaboration than a traditional conference. So people who go along to Plumbers expect to kind of participate, and it is much more interactive than a typical tech conference. Mm-hmm. And it's also split into a number of, there are these micro conferences on various specialized groups. There are special interest groups, and people get together and kind of chew the fat, and there'll be some presentations, and then there'll be discussion around that presentation. So for many years, there's been an Android micro conference, and there will be again this year in Tokyo. And so last year in 24, I gave a presentation at the Android micro conference talking about this lack of community around AOSP. And then we got to the kind of QA and discussion part of the session. So I said, these are things we could do. What do you think? And then I kind of looked out at the people in the room, and they were all looking back at me. And it's at that point it sort of clicked that, okay, if anybody's going to do anything, it's going to have to be me, isn't it? So I said that. So I said, okay, let's do this. Who in this room will help me? And I think 6 or 8 people put their hands up. And at that moment, we started work on AOSP devs. So AOSP-devs.org is the website. And we have, over the last 12 months, we've put together a Discord server. There's quite a lot of channels on that to talk about specific issues with AOSP. There's one on kernel, there's one on HALs, and there's a general channel and so on. There's even one on jobs. If you want a job, go check out the jobs channel. Awesome. And we have a website with some blogs, and We have a newsletter every month, which kind of summarizes what's been going on with Android, with AOSP in the last month. And so we, the group who do this, so there's like 10 people on the steering committee. I'm just one of them. But we're kind of keeping this going, and we have ambitions to make this, into a bigger thing. We want more and more people to join us. So if there is anybody listening to TumpDeer who is working with AOSP, take a look at AOSP devs or send me an email or something, and we'd like to talk to you. So yeah, that's the whole thing. Oh, and just one other quick thing I'll put in a plug for is that there's this thing in Europe called FOSDEM.
Yeah.
FOSDEM is every year. It's in Brussels at the start of February. This year, actually, it's the last day of January and the first day of February. So the weather's always terrible. But then you do have Belgian beer and Belgian waffles and moule et fruits, mussels and French fries. And yeah, everything's good. So anyway, so we're doing a session now on AOSP. It's actually called FOS on Mobile, is the dev room. And there'll be a whole bunch of stuff there about AOSP and all this stuff. So yeah, so we're trying to create a community. Open source is really about community. It's not about free software, although there is free software. So that's it. So Frank, I don't know if you want to, sorry, I'm jumping in here a little bit, but if you want to key into that and talk about the plumbers this year.
Absolutely. So Linux Plumbers is in Tokyo this year. It's December 11th to the 13th, so right around the corner. if you haven't already registered and made your travel plans, you are not going to be there. You can still attend virtually, so you can register and attend virtually, and watch the live streams and participate that way. I'm going to be there. I'm part of the Build Systems micro conference. So Chris mentioned the Android micro conference. There's like 12 of them, maybe more. So there's one around Build Systems, and this is the third year that they've been doing it. And we've got some great speakers. So the leads for this micro conference are Bihan Webster and Philip Ballister. So they're back to lead the micro conference this year. And Joshua Watt is one of the. We call them speakers, but like Chris said, Plumbers is highly interactive. So it's not meant for somebody to go up there and really talk about something. It's supposed to be a discussion, and you're supposed to get into debates and around things. Like you're not supposed to show up there with any answers. Like it's supposed to be like, well, this isn't working out. How do we move things forward? And so in that vein, my presentation is going to be, well, the session that I'm leading is about UEFI Secure Boot and how that integrates with Build Systems, because there's all this signing and rolling of keys and TPMs to get that to work. And so people obviously do it, the major distros do it, but nobody knows how everybody's doing it, and because it's security, right? So nobody wants to talk about it. But I'm trying to get people to talk about it so that people like you and me can do it, and maybe we can create something that the whole community, all the distros can use to do this rather than rolling their own.
Yeah. Very good.
Yeah.
So I think that'll be awesome. Like I think it also fuels some of the cross distro common solution. So I think it's like really good that, you kind of like address some of the common technologies in there and probably come up with some workflows that are useful all across, so that's very useful. So what do you think? What are like, your opinions about cross compilation and native development, especially for embedded systems, essentially moving forward? A lot of these systems have become powerful, but then, it's still, there are certain cost of cross compilation in terms of complexity and other ways. And a lot of developers are, accustomed with native development. So how do you reconcile that?
Shall I take that?
If
So
you want to, yeah, you first, Chris. I'll have a lot to say, but you go first.
okay, well, I'll keep it short. So I mean, one of the things that's always marked out embedded development is that we almost always do it in a cross-compile environment. And that causes no end of pain. So why do we do it? The reason is that the target device generally isn't well set up for software development. Even these days, with more powerful chips, the software itself has got more powerful. So it's got bigger and takes longer to compile. So trying to build everything on your target device often isn't the best way of doing things. It doesn't have enough RAM, it doesn't have enough storage, doesn't have the right peripherals, and so on. So generally speaking, it makes a lot more sense to have a big, powerful computer, your development system that you cross-compile on, and then you download the images onto the target system. It just kind of fits better with the way that things work. It also works quite well also with doing remote debugging. So you have the target device you're developing for, and then the development device you're developing on. And it makes sense to use cross debug tools, remote debug tools, so that you can monitor the one computer from the other. So remote debugging is a very useful way of doing things. So in a nutshell, then, that's essentially why we embedded developers tend to prefer cross-compile rather than native compile. Not to say you can't do it, but in most cases it makes more sense to do cross-compile. So that's my 2 cents worth.
How about you, Frank?
I'm going to take the opposing stance.
Good.
And I'm going to say you don't need cross compilers anymore. You just compile natively inside a container, running on QEMU. Like that's, so GitHub Actions, has like ARM, runners now. So that will, compile 64-bit ARM binaries for you. And you can just deploy those inside a container image. And
so you're not compiling on the actual the remote. Sorry, the embedded hardware itself. You're
an emulator.
You're building it on an emulator running in QEMU or something similar. Yeah. I mean that's a great way of doing things.
Yeah, I think the emulator kind of is a middle way somewhere in between where, you may not be able to do everything on it one, but, it gets you 90% there, sometimes more. But yeah, I think certainly a good workflow.
Yeah, one thing Kim and I have been discussing is maybe building systems with Yocto, but maybe doing some of the application development on the target system. So not trying to build lots of stuff, but maybe the stuff where you're iterating quickly. There may be some scenarios like that makes sense, but it's still early. We're still exploring, so we'll see where it goes.
Yeah, and Yocto does have on-device SDK, so you include that in your images. And like if you have, one of these modern like Tegras, they have like 12 core monsters sitting there with like 64 GB RAM, and I think all those are pretty powerful computers that you can leverage to do some of that. Not for really doing the full like system deployment and production kind of workflows, but for developer workflows.
When I did Buildroot, what really used to drive my team up the wall was the fact that there was no compiler on the target device. They're just like, how do I do anything? Like, I can't compile a program. And I'm just like, well, you have SSH, you can SCP the binaries over and then, do that. And then the other thing that drove them mad was like, the file system is read only. So it's like you power cycle and everything they did is gone. And they're like, this is stupid. You're killing me,
Yeah. I think there's a production system and there's a developer system, so yeah, I mean, you have to be careful about like, if you're developing on a production system, there is pain, right? And you have to know.
But you do have to remember to leave the compiler out when you ship the system, because you generally don't want to ship your development and SDK in the production device.
Mm-hmm.
Yeah.
So it comes a little bit back to this kind of golden master thing.
Yeah.
But yeah, the world has moved on. I don't get complaints. I'm still battling with containers. I need to up my game a little bit.
Yeah. So one of the things we think about, like, what's the ideal workflow for embedded Linux? And Frank, you mentioned containers. So are you suggesting you actually run the containers on the target as well?
Yeah.
Like deliver software to the embedded target using containers?
I am. I've done it. That's what my customers want.
Yeah, so like Tordex is into that in a big way. We've talked to them, and so it seems like that's something that various people are doing now. So very interesting.
Yeah, I mean, I've explored other avenues. So I've really gotten into systemd, and you talk about communities. That's another great open source community is the systemd community. And so, they have this concept of system extension images, which are kind of like containers. I mean, they're just, it's just like a tarball, a squash FS image, but it's an overlay on top of the root file system, each one of these extension images. And so it's a great way to bundle and deploy software. Just like containers are a great way to bundle and deploy software.
Yeah, I think, it's an art how you compose the system, right? So composability essentially is very key these days. There are so many technologies out there, and I think if you understand the use cases, one may be better than others. And how you put that together is really, make or break for a lot of products, right? So sometimes you take the good old way of doing it and then, to this new use case, and that might be limiting, right? As you might have seen, Frank. But I think there are different ways to compose your system. And if you have like systems and platforms that like enable you to put together these workflows, that's what you're looking for, to get going. Those are like very powerful tools.
Yeah, and the systemd way of doing it, like it plays very nicely with Yocto, because like, what do you do with Yocto? You're generating all these images. I mean, usually we're generating the full Linux image, with the entire root file system, but there's nothing stopping you from just creating an image that has like your application with all its dependencies on it.
Yeah.
And because you're using Yocto to do it, you're still cross compiling and doing all the things we've always done in embedded.
Yeah. I think that's an interesting way to put the system together, I would say. It kind of gives you more agility in terms of moving forward. You're more nimble because, you can update probably one container rather than the whole system. So in certain use cases, I can see a lot of use cases, that fits into this kind of scenario, for sure.
But then things can go wrong, right? When you have multiple overlay images that interact in unexpected ways, that you could be bricking your whole fleet.
Yeah.
Yeah, there's definitely no free lunch here. It's hard any way you slice it. So
yeah.
Well, I mean, if you're shipping, let's just say if you've got a fleet of thousands or hundreds of thousands or millions of devices out there, then you've got to be pretty sure when you ship an update that it's going to work. Otherwise, you're toast.
Yeah, I think that's very, very important. That there will be 1 out of a million. That something will go wrong. The temperature is too high, or whatever. A bit flips. Invariably, it's physical systems in the end anyway. So and then hell breaks loose. So we will basically be better served if we know that it's what it is supposed to do, what it will do there. There is no much difference between them. If there are too many states.
I think that's one thing that separates embedded engineers from regular software engineers, because we're generally working with systems which don't have an operator or somebody to look over it and press the reset button when it goes wrong. So we do have to be extra cautious about the stuff that we do and the way we do it.
Yeah. Some of them have systems deep in the oceans, right?
I've certainly spoken to people doing oil exploration stuff, and they're 2 miles down. And you can't easily get down there to press the button if it goes wrong. It's a real problem.
Right. It'll be expensive.
It would be expensive. Yeah.
Cool. So, what are some of the common pitfalls you've seen so far in embedded Linux development? The mistakes that people make all the time, and then anything pops up in your mind?
Yeah, like shipping devices running Ubuntu. That's the big one, right? Like everybody thinks they can that's okay, that they can just do that and everything will be fine.
Yeah,
I think Mark Shuttleworth is writing an email to you right now.
I think on a lighter note what he mentioned, but I think in general it kind of like dovetails into what Chris was mentioning on the golden master image concept, right? And this is kind of the ingredients for that sort of stuff. If you are doing that, then I guess that's where it ends up in, right? So certainly I think one has to be aware of that. And what I have seen is compliance, so people don't think about compliance ahead of time. And then, it becomes like a showstopper, for you to ship the product. And it's very expensive at the end of your development cycle or what have you and everybody's waiting right in that now. And you're kind of pulling things together at the last hour. The other one I've seen is OTAs. People don't think about that ahead of time. Because OTAs involve your flash layout knowledge and a lot of stuff. And in disconnected systems in the past, okay, not a big deal because you'll flash it once and probably never update the software on it. But nowadays everything is connected. So if you don't think OTA ahead of time, and you try to retrofit it, it's going to cause pain. And I see that again and again. Like people put together, it's booting, and then they start adding stuff, and then it becomes okay, all features working, let's ship it. Sometimes they ship it, and then there is oops, how do I update it now?
Yeah, and particularly in Europe with the CRA, the Cyber Resilience Act coming in sometime next year. I mean, that's a game changer because now it's a legal requirement that you have to be able to update software. So you have to plan all this stuff in, and you can't retrofit it. Well, you can, but it's hard. It works much better if you plan it in from the beginning. Yeah. And likewise, all the secure boot stuff and all that stuff needs to be designed in. You can't build a proof of concept and ship it. You've got to design the whole thing in from scratch. And probably I would say that the biggest mistake I see people doing is exactly that. Somebody creates a POC, proof of concept. Somebody in the marketing department says, "Hey, that's cool," and without really thinking about it too much more, they end up shipping it, and then nightmare.
Yeah.
So you've got to take it seriously. Embedded is not the same as normal computing.
Absolutely. Yeah, I think
that's why you need to buy our book.
Definitely. Yeah, I think so. Speaking of a book, are we looking for fifth edition sometime soon? Or I know fourth edition just came out, but are you already working on the fifth edition? Or
No. So we were on another podcast, and I was explaining how a book like this has like a 4-year life cycle typically before it makes sense to do another
I see.
edition. So there's at least 3 more years to go.
Cool.
I'm
So
sure
what
there
are
will
some of-
be a fifth edition. Sorry, I'm sure there will be a fifth edition. Where exactly when and who's writing it is TBD, I think.
Okay.
Yeah, so I've actually been getting. I haven't gotten pressure from Pact yet. It's too soon.
Well, you will.
Probably in like 6 months, they're going to start asking me about the fifth edition and when that's coming. And so here's my stance on it. The reason I waited as long as I did to do the fourth was because there wasn't a 64-bit ARM dev board besides the Pi, right? Like really that I thought would be acceptable for the book. Like I needed a TI dev board because like, you know, the BeagleBone Black was so TI. It's a TI SoC, and so I wanted to stick with that. So I was waiting for TI. Well, I was waiting for BeagleBoard to ship a 64-bit ARM dev board, and they did. And so then I said like, okay, I'll update the book. Now, the way I feel about it is like people are so into RISC-V now that like, okay, once there's like a RISC-V, like RVA23 dev board that's like getting traction, then yeah, okay. I think it might make sense to, you know, finally go RISC-V with the book. I'll keep the Pi because like everybody has a Pi, right? I'm not getting rid of the Pi, but
you don't have to because
yeah,
there's an Orange Pi that runs RISC-V, so you can have it.
yeah, no, but I mean like I'm talking about the real Pi.
Sure.
Well, I hear good things about the Pi 6 when it comes out, so I think that might be an interesting one to go for.
Yeah.
But I think the Pi 6 might be a bit more open than the previous Pis.
That's good.
But yeah, but I mean, you're right. Having a good dev board is important, and you know, you've got to put it out there. There are other people making dev boards based on 64-bit ARM, but the TI guys, and also the big shout out to the BeagleBoard.org guys. They do a fantastic job at packaging and supporting the software. And one of the great things, I think Jason Kritner was instrumental in doing this, was to open source the graphic drivers for the TI, whichever chip it is, AMS62XX, whichever chip it is that's on the Beagle Play anyhow. So they are really great at keeping everything open and maintaining it. I mean, I think you can still buy BeagleBone Black. You can still, you know, it's not end of life. So it's just a great ecosystem to key into for this kind of thing.
Right.
Yeah, they're great. I sent Jason a copy of the book like right when it came out, and Robert Nelson, who works for DigiKey and builds all the Debian images for the Beagle boards. BeagleBoard has a Discord server that's very active, and so as I was writing the book, especially like all the U-boot stuff, like Robert helped me out a lot in those early chapters.
Yeah, Yeah, he's an amazing developer. Yeah.
Yeah.
Mm.
So what technologies interest you in future? Or what are you kind of dabbling with or looking anxiously?
You want to go first, Chris?
Well, okay, so a bit of a reveal here, which is that I'm kind of semi-retired now, so I don't actually do much coding apart from just fitting around. So I don't really have a good answer to that question. I was thinking about this before we started the podcast. So very quickly, I would take a bit of a left turn on this and say the technology that interests me most actually is open source, which isn't a technology; it's a methodology. But open source has made such a big difference over the last 20 years, 25 years since I've been doing this stuff. And it's gone from being something really quite wacky and misunderstood to being something that's mainstream and also misunderstood. But it has become fundamental to the way this is the way it works. So my future hope for this is that open source continues to grow, and that we as a group of 4 people here and as the wider community kind of show people what open source is meant to be. And like I say, open source is not just free software; it's a community.
Yeah.
So that's my slightly side swerve on that.
Yeah, the interesting thing about open source is not only the product but the process, and that's really the amazing part, in my opinion. It's really changed the way software is developed, even in commercial endeavors, I feel.
That's the key,
almost
right?
nothing.
Yeah. I mean, even if you apply it to do your commercial, like your closed source software development, it comes out better, right? So if you just learn the process and, you can do that. So yeah, a lot of times people kind of, like, as Chris said, misunderstand it.
That's why I'm so excited about Tokyo and plumbers, is because, like, those are the real heads, right? The Linux kernel devs. It's like I literally had to fight my way to get in there. Like it's really there's no marketing, there are no CEOs, there's like none of that. It's just like it's just engineers, trying to solve problems. And that's, to me, that's the strength of the open source community.
Yeah.
So any tools that you use, that you recommend, your setups you like to talk about or recommend, like your editors or, your process, your daily drivers?
This is where you get to talk about AI, Frank.
Okay. All right. Well,
all right.
So in terms of like technologies, like you've got me down this rabbit hole of Nix, Cam. So the conversations
I'm sorry.
we've had about Nix have, like, so now I'm getting into Nix and I'm seeing how people are using it. And so there's people doing, like, they're using Nix to do like stuff with, like, NVIDIA Jetsons and stuff. And it's like this whole world of like Nix on NVIDIA that's like, I'm like, wow, that's pretty cool.
Yeah.
Can I just ask a question here, because I'm not familiar with Nix? What is Nix?
Nix is another build system, so to speak, right? So it's basically a build tool, right? So Nix is, you can think of like what BitBake is, right? In Yocto speak.
Okay.
And then, there's a Nix OS, which is like an operating system put together using the Nix methodology. So it's pretty much, there's a one-to-one analogy between, say, Yocto, Open Embedded / BitBake and Nix. Nix is portable across multiple platforms. Like, you can build your application using Nix for Mac and for Windows. I don't know when they do Windows yet, but essentially for another other kind of Linuxes. And I think it's that build tool essentially to begin with, and then it has like some philosophy around it. The way they put together system. It's a very declarative method, to put your build rules together, so it's fairly reproducible. I think the fundamentals they thought about are pretty sound. Just capturing your build rules in a way that is deterministic and can help you to recreate, or we talked about repeatable systems very easily.
Okay, cool.
Yeah. And there's the NixOS, which is kind of, you can download it and you can install it on a system, right? And you can play with it. You can use like, KDE, GNOME, and all those like usual suspects, whatever you use for your IDEs, everything is there. Like S-State, there is a store, like Nix Store. So it basically has, thousands of builds of, a single package with different configurations. And it calculates which one your system needs, and then that's the key piece of the Nix build tool. Basically, given the expression, it will always produce the same system, right? That's the strong part of it. And like Yocto, it is complex. That's the other side of it. So
yeah. So now finally, AI vibe coding. I'm doing this, right? Just like everybody's doing it. You're probably doing it. I know you've done some yourself, Chris.
A little bit.
So I don't know what all of you are using, but I've gotten into Claude Code. Like that seems to be the most popular one. Like I skipped the whole like cursor IDE thing. Like I've only been vibe coding or trying to do any of it since April. That's the first time I installed any of these tools, and it's been great. Like I don't write code anymore. Okay, well I'll see. It's great for certain things. It's horrible at Yocto and BitBake. Like it just cannot do it. And I've already alluded to that before, but like if you're doing say DevOps, which I'm doing a lot of that for money now, and which is like Terraform and OpenTofu and AWS services. It's wonderful for that kind of stuff. Like I just I have a command line prompt, and I tell it to read my code and explain it to me, and then I tell it to like add a certain feature in a certain place, and it's proven to be very effective in that regard. So I feel like the world has been turned upside down, in terms of like what it means to be a programmer these days. Or well, you're not a programmer. The LLMs are programming. You're like you're telling the LLMs what to do.
Yeah, it is amazing at infrastructure, like you said. I mean, shell scripts is one thing that it can crank out a shell script that works. It's just amazing that that I would struggle with for some time to get regular expressions right and all that. So
I think I delegated tasks that I don't want to do, essentially where I'm not good at, but it does do. I mean, if things I know, and I know that it doesn't answer very well a lot of times, so I'm a little extra careful there. But there are like certain things, as Cliff mentioned, where I know that it's a support task. It doesn't matter if it is inefficient or whatever, but let it do it. So those kind of things, I really use it. So it's pretty good in a lot of those regards. Pretty nice. So any reading recommendations or TVs, shows, podcasts, other things that, you guys would like to share?
Oh boy, I listen to a lot of podcasts. Like, a really funny one that Chris turned me on to because he was a guest on it is the Linux in-laws.
No, I've never heard of that one.
Yeah,
that's something else. You ought to check out Linux in-laws. Yeah.
That's a really weird podcast.
Mhm.
We covered a lot of
Okay.
ground. Yeah, I finally worked out why it's called the Linux In-Laws, because there's another podcast called the Linux Outlaws.
I see.
So then you've got the Outlaws, and then these guys, which is a British guy and a German guy, call themselves the Linux In-Laws. Yeah, they're quite opinionated. So you guys, Cliff and Cam, I mean, you're great. You're you're asking the questions and letting us answer them. If you go onto Linux In-Laws, if they're listening, they are much more confrontational, let's put it that way. So you've got to be on your toes if you're going to be talking with these guys. But it's a lot of fun all the same.
Sure. Yeah. It's a different kind of conversations, I'm pretty sure. I mean,
I prefer your way of doing it, I've got to say.
Yeah. Very cool. Yeah. So I'm sure that, one of the reading recommendations would be like Mastering Embedded Linux, of course, right?
100%. It's the best book.
It's the best book. And if you're getting into, embedded systems. So I want you to, advise a listener who is moving from, say, a microcontroller development into, say, Linux-based SOCs, right? And what is like realistically a first project he or she should take on, and should he buy a book, and then just kind of like if you can touch base on that one, what will be your guidance?
Well, I mean, obviously, I'm going to plug our book, right? Like, our book is the best, bar none. In terms of projects, so one thing in our book is one of the exercises is to stand up a GATT server on the Raspberry Pi 4. So this is a Bluetooth low energy server. A lot of mobile apps, when they connect to a device, they connect to it over Bluetooth, and so there's like there's the whole pairing process and all that. So by standing up this GATT server, which is all written in Python, and pretty easy to build. I actually build it as a containerized app in the book. So that's one exercise that I think is pretty good. Outside of the book, a lot of people are doing like great stuff with computer vision, right? There's all these these computer vision models like YOLO and a lot of people doing stuff on NVIDIA Jetsons, computer vision, and the other thing. Now I don't know anything about this stuff, but like ROS is a big thing, robot operating system, and getting robot arms to do things. I can see how that's a lot of fun, but it's not how we do things in embedded, right? It's hard to productize something that you've done in ROS, but hey, at least you have something worth productizing to begin with, right?
Yeah. I think learning has to be fun, and I think it could be fun if you do something like that. So, how about you, Chris?
Well, I was going to say that I always start off with the very basics, which is how to turn an LED on and off. So always with a new system, a new dev board, whatever. And I would recommend doing this with your Raspberry Pi or your BeagleBone Play or whatever else you may have. It is a great boost, really, just to write. You spend a lot of time getting the environment set up and building all this stuff, and then hey, I can now type a little program that will turn the LED on and off. And I've done this as a demo many times at conferences and whatever, and every time you get a round of applause. So I do a live demo. So I say, okay, here's Yocto. Here's how you build Yocto. And now to prove that it's working, I am going to type this command on my laptop, and it's going to turn that LED on. And I type the command, live on the screen, and the LED turns on, and everybody goes, "Whoa!" And I think, yes, done it again. I've done it again.
Yeah.
So it's kind of trivial, but it's also if you're literally starting out from scratch, I really would start from there. Where do you go from that? Well, it depends on what you want to do. If you want to make, if you've got some motors and relays and whatever, you want to make them do something, sure, go ahead, do that. It's a little bit more tricky and requires a bit more hardware. The other fun little thing that I did one time at a workshop is we built using a Raspberry Pi, we built a smart doorbell. So that involved a camera, some RTSP communication to send the video images, where the button you could press, where there was a beeper that went beep, which everybody enjoyed a lot. So that brought in a lot of useful things. The amount of hardware you need for that is kind of quite trivial. It's like $50 worth of hardware you might need for a camera and a box of wires and diodes and transistors and whatever. So you can do a lot of stuff without huge investment in either money or indeed in time, for that matter. And one of the things I'd like to say is, why would you want to buy our book when all of this stuff is available for free online? And the answer is that, sure, all this stuff is available, but piecing it all together is quite tricky. Yeah, so the benefit of a book, I mean, it's not cheap, I admit that, but the benefit of having a book is it gives you a lot of context, and it gives you a path from wherever you are starting from to the final stage. So you can kind of, whatever your skill level is, you can jump in at the appropriate chapter and then kind of take it from there onwards. Doing that from scratch by yourself is much harder. So hey, you'll get the $40 back in time in no time. So it's a good deal, believe me.
Yeah. I think your table of content is almost like a roadmap. If somebody goes to it, it's like a roadmap if you're wanting an embedded Linux career. That's how I see it, right? So and then you choose the order, which order you want to learn, right? And you might be at a certain skill level, maybe you start from there. So I think that's huge.
And it's kind of the chapters are arranged so that there is a logical progression from the very basic, setting up your build environment, Yocto or build root or whatever, setting up your board and running your first program, all the way through to various programming techniques and containerization and over-the-air update and some quite sophisticated stuff. There's a whole bunch of real-time stuff in there if you want to do real-time programming. You can go off in lots of different directions. And we obviously don't cover everything because that's impossible. But I do believe that we cover a pretty good range of things.
I was surprised at the breadth of the book. I mean, it just seems like a very good reference, to pretty much.
Thanks for saying that. I mean, that certainly is what we're trying to achieve here.
Awesome. So I think we are at the end of our journey today. So any last few words?
I would need to say thank you to you, Cam, and to you, Cliff, for having us along. It's been great shooting the breeze about all this stuff. This is my life. This has been my life for the last 25 years. And I continue enjoying this stuff, and I hope I will do for a lot longer. So, hey, it's been great being here.
I echo that sentiment. And I just want to tell, people who are young people getting started in their careers, hardware is fun.
It is fun.
There's nothing else like it. And if it turns out that that's what you love, like, you know, like everybody's going to do AI, right? You're going to be competing against the whole world, right? Like for a small number of jobs where, like, you know, they're going to pay you $100 million to join Meta or whatever. But the hardware is fun. So
Yeah.
Yeah, a lot of opportunity there. So appreciate that.
Yeah.
So
Absolutely. Yeah.
yeah.
And nobody else is doing it. So yeah,
Yeah.
Yeah.
you won't have so much competition.
We definitely need young people in this space. So that's for
Do
sure.
yeah. I mean, look at me. I'm
Yeah. Me
no
too.
hair, beard. Yeah.
So, well, we
Well.
definitely appreciate all our listeners, and if you have any feedback, please reach out to us at the normal places we hang out. So, thank you, appreciate it. Take care.
bye.
Yep. Take care. Bye-bye.
Bye.